Question 15. A researcher is using the statistical investigation process to investigate a possible relationship between average number of minutes per day a person spends watching television and the average number of minutes per day the person spends exercising. Part A says state the statistical question being posed. So basically we need to take this information and turn it into a question. So I would write, is there a relationship between the average number of minutes per day a person spends watching TV and the average number of minutes per day they spend exercising. Question mark. Now, for part B, it says participants were asked to record the number of minutes they spent watching television each day and the number of minutes they spent exercising each day. The averages for each participant were recorded and graphed, and a line of best fit was included. From the graph, identify the dependent variable. So the dependent variable is the one that we don't change. It's the one that changes based on the one that we change. So it depends on our thing that we're changing. So in this set of data for this experiment, we are changing the number of minutes per day someone watches television, and then we see as a result of that how much they exercise. So therefore, the result of the thing that we control, the dependent variable, is this y-axis, and you're going to find that the dependent is going to be the y always, and the independent is going to be the x. So over here from the graph, identify the dependent variable. This is average minutes per day exercising. So average minutes per day exercising. For part C, it says describe the bivariate dataset in terms of its form and direction. So its form is the shape of it. So we can see that this form, the shape of this, is linear. Now, if the data points kind of were dotted around to create a general shape like this would be like parabolic, right? Or we could say nonlinear as well. So it's just the general shape all of your data points take. So this is linear for form. And for direction, we want to look, okay, this is linear. The direction of a linear graph can either be positive or negative. So for this graph, as the average minutes per day watching television increases, the average minutes per day exercising, it decreases. So this is a negative direction. Okay, and then for part D, it says the points 0, 70 and 60, 10 lie on the line of best fit. By first plotting these points on the graph, find the gradient and the y-intercept of the line of best fit. So let's plot it. 0, 70 first. 0 is your x value, 70 is your y value, so that lies here. And then 60, 10. So 60 is our x value, and then 10 is our y value, so this lies here. Okay, so then it says, okay, we plot these points. Now find the gradient and the y-intercept of the line of best fit. So for the gradient, that equals y2 minus y1 over x2 minus x1. So something that can be confusing is, what do we label as x1, y1, and what do we label as x2, y2? So let's just label these points first with their coordinates. Now, okay, this is how I determine what my x1, y1, x2, x2 are. I like to imagine that I'm reading a book. So in Australia, we read books from left to right. And the first point that I hit when reading left to right is this point here. So this is going to be my x1, y1. And then as I keep reading across, then I hit this point here. So this is going to be my x2, y2. So the 6010 is x2, y2. So let's come back down here. This is x1, y1, x2, y2. So if we sub that into our formula, y2 is 10 minus y1, which is 70, over x2, 60, minus x1, 0. So this equals 10 minus 70 is minus 60, over 60 minus 0, 60. And if we simplify minus 60 over 60, that is minus 1. So that's what the gradient is. And then they're saying find the gradient and the y-intercept of the line. The y-intercept is represented as c because of our formula is y equals mx plus c. So this is the y-intercept here. And the y-intercept is just when the linear line cuts the y-axis. So that is when the x value is 0, because that's where the y-axis lies when the x value is 0. So they've actually pretty much given us the answer here because they gave the coordinate 0, 70. So we know that the y-intercept is going to be 70. So we can just write that here. And then finally, we have part E. It says, explain why it is not appropriate to extrapolate the line of best fit to predict the average number of minutes of exercise per day for somebody who watches an average of 2 hours of television per day. So this word extrapolate, I'm going to highlight it. There's an opposite of this, and the opposite is called interpolate. So I'm going to explain what extrapolate and interpolate is. Interpolate, I'll start with that, is if we want to find the value of a point that is within this data range. So like, let's say we want to find this point here, right? It's very much within the data range. We have recorded data before and after this point, and that is how we got our line of best fit. So it's pretty reliable, pretty accurate. And then extrapolate is if we have a number, so on this x-axis, if we have a number after 70, for example, like it's out here somewhere, and we want to try and find what the average minutes per day of exercise is for that amount of TV watching. And because it's outside of the range of data we collected, it may not always be reliable. So you can't assume that it's going to be an accurate answer. So we basically have to write that in the answer of this question, because they're asking why we can't extrapolate if somebody watches 2 hours of television per day. So 2 hours of television equals 120 minutes. And then if we look at this graph, right, it's all recorded in minutes, 120 would be like way out here. So that is extrapolating, and we can't assume that. So 2 hours equals 120 minutes, which is well outside the recorded data. And the relationship between the x and y values cannot be assumed. Outside the range of the recorded data.